Section 4 does nothing else than review the amine synthesis reactions we've learned previously. And there are 3 reactions we need to refresh our memory with and make sure we memorize them and make sure they're on flashcards. So the first reaction here is the synthesis of primary amines from alkyl halides. So if we have a chiral alkyl halide like this one here, which is R2-bromobutane, and we treat this with sodium cyanide and a polar aprotic solvent like DMSO. This proceeds via SN2 with inversion of the leaving group, okay? And so the nitrile group now becomes installed on the top, okay? And so if we treat that with LAH and H2O, we can reduce that down to the primary amine. Another reaction involves starting with carboxylic acids. If you treat this with thiochloride, that makes the acid chloride, and then if you treat this with excess ammonia, you generate your primary amide. If you treat that with lithium aluminum hydride followed by water, you get the primary amine. If you use primary amines or secondary amines, you can make the secondary or tertiary amines at the very end, respectively. Anilines can also be made, remember, from benzene. So if we take benzene or other aromatic rings with interesting side groups, we can do an electrophilic aromatic nitration with nitric acid and sulfuric acid to give us a nitrobenzene or nitroaromatic. And then we can reduce that with iron and hydrochloric acid or tin and hydrochloric acid to give you aniline. These are the 3 reactions we'll incorporate in the moving ahead in the chapter. Okay, so that's it for this section. Thanks. So again, these are called conceptual checkpoints. It's good for self-assessing your knowledge to see if you're able to do these. Of course, as always, pause the video, do this yourself, and then come back and watch the video to see if you got it, or what I was thinking. So we want to draw the structure of an alkyl halide or a carboxylic acid that might serve as a precursor in the preparation of each of the following. So for part A, I'll start with the alkyl halide. So what you want to do is subtract 1 carbon. Okay, so there's 1, 2, 3, 4 carbons. Here we have 3. So if you add sodium cyanide, okay, to this, you will increase the chain length by 1 with that nitrile group. And then if you treat this with LAH and water, you will get the additional carbon there, you know, in your molecule that you need. So watch out for that if you're using sodium cyanide. If you're using the carboxylic acid, you want to keep all 4 carbons there, okay? So this includes all of the 4 carbons we need. And so again, you want to treat this with thiochloride. That'll make the acid chloride, still with 4 carbons. Treat this with excess ammonia. That's going to make the butanamide, and then treat that with LAH and water to form the same molecule here where you've reduced that carbon there, okay? So that has 4 carbons. So that's the general idea there. Now if you do B, so we want to subtract a carbon to give you the alkyl halide, okay? So that could be used to make the target molecule. We would add sodium cyanide, LAH, water, and so again, that carbon there would come from cyanide. Or we could start with a carboxylic acid that has the necessary number of carbons. Just takes a while to write all the reagents in there, but that would be the carboxylic acid, okay? For C, we want to subtract a carbon to make the alkyl halide. So the cyanide would install the missing carbon. or we start from our carboxylic acid that has all of the required carbons. Okay, so that's how you do this problem. I hope you got the same answers. Thanks for watching, and stay tuned for more videos on Chapter 23 when we synthesize more interesting amines.